So hello everyone. Hope you are able to see me and hear me. Hello everyone and welcome to the session. We are going to talk about financial analytics. Okay, and this training will go on for approximately, I should say, 8 hours, or maybe slightly less than that. At least you'll have at a bare minimum 5 sessions from my side. Or I should say we'll have at a bare minimum at least 6 sessions. And we will first talk about the financial analytics applications, and then we shall proceed further. Again, you have to excuse me for a quick minute while I just enable. Yes. Okay, hope you guys are able to see me. So I just enabled some light to ensure that you guys can see. Okay, so let's get started with financial analytics, the module 1. As part of this, we are going to talk about a few of the amazing applications in the space of financial analytics. And financial analytics is part of finance. However, we have something called as FSI, or in a certain companies, they call it as BFSI. FSI stands for Financial Services Insurance, and BFSI stands for Banking Financial Services Insurance. But then our focus will not be on banking, or our focus will not be on any specific, I should say, sector. Within this industry called FSI or BFSI, you'll have a lot of sectors. You'll have sectors such as banking sector, okay, or you'll have insurance as a sector, or non-banking financial corporation is one sector, or your cryptocurrency would fall into one sector. Investment banking would be part of one sector. So all these are various sectors. Okay? And we are going to touch upon the entire plethora of financial services insurance. While we have separately banking analytics, we have separate modules called as insurance analytics. Okay, we have a lot of things that we have started. And I'm extremely proud to tell you all that we have started 56 domain analytics trainings. Though we will not be able to give away everything for free, at least we will ensure that we give you a gist of these things. And every month there will be 14 new domain analytics trainings that we intend to launch. And there will be obviously 14 different trainers. And I will be taking, one of the domains every month. And we'll be training, you all on different domains. It is extremely imperative, friends, for you to become a successful data scientist, that you have good domain knowledge. Okay, domain knowledge is extremely important. And that is the reason why we have come up with this. Because a lot of people, just by learning regular data science content, are unable to crack a job. They are not getting jobs. Or maybe the competition is growing now. So a lot of people are getting trained and coming and attending interviews. We want to give our participants, our students, an edge over the others. How can we do that? We can do that by basically providing them with domain analytics. So ensure that you pick up at least one domain which actually motivates you or interests you, and gain expertise on that. Start reading more about that domain. Start reading a lot of machine learning use cases or deep learning use cases pertaining to that. And that is how one gains knowledge in the space of a specific industry or a sector or a domain. All right. Having said that, I would love to get started with this basics, because a lot of people still, whomever I encounter, they ask me this question on, hey, Bharani, what is the difference between artificial intelligence, data science, data mining, deep learning? I keep hearing a lot of buzzwords: reinforcement learning, self-supervised learning, semi-supervised learning, supervised learning, unsupervised learning. People keep talking about a lot of things. And we really go crazy, and we really don't understand what is the role of each of these terms. And they also get confused between the different roles that exist. They keep asking me questions such as, what do you mean by a data analyst? What do they do? Data scientist, what does a data scientist do? A data engineer, what does a data engineer do? So on and so forth. They have a bunch of questions in their mind. So I would like to take quick, probably 10 minutes or so, and explain about these aspects. And I think I would just need one quick minute. Okay. So I'm not sure. I'm asked to make it YouTube live, but I do not see an option for me. That's okay. So we shall see how things go. I'm anyways recording the session, and we will see how to place that on the YouTube channel. Okay. So we can also stream it live now. Also, I can do it, but I think given the time constraints and all that, that's okay. We shall proceed. All right. So first thing is artificial intelligence. People keep asking me on, what do you mean by artificial intelligence? If you can automate anything which is done by humans, if you can take human intelligence and if you can automate it, that would be called as artificial intelligence. For example, people invest in stock market, right? You all invest in stock market. What do we do on stock market? We buy certain stocks of different companies such as TCS, Google, Infosys, whatever be it. And then we sell it as need be. Well, once we make some money, once we get some profits, we tend to sell it. So this is done by humans. What activities do? They buy stocks, they sell stocks. How many stocks do I need to sell? How many stocks do I need to buy? Which company stocks do I need to buy? Which company stocks do I need to sell? These are a few decisions that we need to make. And this is done based on human intelligence. So you go do a lot of research about what are the various companies which exist, how strong are those companies, right? And are those companies blue chip companies? Blue chip means their foundations are very strong, like maybe TCS, Infosys, etc. They're well established. So on and so forth. You do a lot of analysis. And why do you do all this? You do all of these things to increase your return on investment, or you're doing all these things to maximize your return on investment. If I'm going to invest $100, how much money am I going to get back? Would I get back 110 rupees, or would I get 120 rupees, whatever, right? That's maximizing your, or that is return on investment, and you want to maximize that part. Can I automate it? Yes, you can. And nowadays, robotic trading is becoming extremely famous. How can I make use of robots? And then how can they actually perform trading automatically, algorithmic trading? And here, there is a new technique which is called as reinforcement learning. Reinforcement learning, which is actually used. So the traditional algorithmic trading techniques are pipped in favor of reinforcement learning. Reinforcement learning is so powerful that if you have thousands of stocks, thousands of companies, and millions of dollars are sold, millions of dollars are purchased on a daily basis. Sometimes you gain money, sometimes you lose money. So all these things happen. Reinforcement learning is used when you have such a complicated scenario where you have thousands and thousands of decisions to be made every second. Tell me, how many stocks of TCS should I purchase? How many stocks of Infosys should I sell? How many stocks of Google should I hold on to? Do I need to purchase any new stock? Do I need to sell any remaining stock? Every second, such that I maximize my profit. So when you have such very complicated data where you cannot define the rules, you cannot say that at 9 a.m. when the stock market starts, buy TCS 10 stocks, Infosys sell 20 stocks. You cannot define such rules because there are millions and billions of rules that you need to formulate every second. Okay, if you were to do it. Maybe on weekdays, stocks behave in a certain way. Weekends, when it's approaching weekend period, maybe stocks behave in a certain other fashion. During rainy season, if the rains are heavy, then stocks might behave in a certain fashion. If it doesn't rain properly, then stocks might behave in a certain fashion. So stocks keep behaving in a specific manner, which is beyond our control to manually formulate the rules. In those kind of scenarios, you can automate it using robotic trading, using techniques such as reinforcement learning. But the beauty here is that the moment you automate the human intelligence artificially, it would be called as artificial intelligence. But to build AI applications, you would need data science techniques. You need knowledge about data science. Any person working on data would be called as data scientists if they are working on data and predicting the future. So let me write that part also. If you are going to work on data and if you're going to predict, of course, predicting happens for future only. Then You would be called as a data scientist, and your profession would be called as data science profession. What will be the stock value? What will be the stock market value 5 months down the lane? Okay, by what percentage will your portfolio grow in the next 3 months? When you are going to answer these kind of questions, then you tend to be called as a data scientist. And the field that you work is called as data science. And here I wish to take one step back and explain about the rules at this point of time, right? So if I call the current moment now as present, and if I take the entire stock market data until now, Bombay Stock Exchange or National Stock Exchange, if I take that data, okay, and then that means I'm taking past data until now. If I take the data, and then if I analyze to understand what happened until now, did the stock value increase or did the stock value decrease? Until which period did stock value increase? Then when did it stop dropping? Okay, month on month, year on year, week on week, day on day. If I do those analysis on what happened until now, so I'll take the past data and I'll talk about what happened until now. Then that is the job of a data analyst. And you'd be called as working in the space of data analytics. Data analyst obviously works in the space of data analytics. Then you have future. If you talk about what will be the stock value in the next 3 months, what will be national stock exchange value in the next 3 months, in the next 4 months, in the next 5 months. When you talk about future, you'll be called as a data scientist. And the profession that you work in is called as data science. Having said this, data scientist is a person who is also expected to have knowledge about data analytics. This guy should also have knowledge about data analytics. Then you have another role called as data engineer. To work on data analytics or data science, you need data. Data might reside in a database. You either might want to take the data and connect that to one of the business intelligence tools, such as Tableau or Power BI or Click, etc. You might want to take that data from the database and perform business intelligence work. Business intelligence work means you generate reports and dashboards for various stakeholders. And people usually use tools such as Tableau, Power BI, Click, etc. Python also can be used, but majorly these tools are used. And you might also want to use that data and connect to maybe Python and build your models. Maybe you want to build your predictive models, wherein you predict the future. Once you build the models, for the customers to use these, you might want to build mobile applications, or you might want to build web applications, or you might want to integrate with some business applications that you already have in your organization. No matter what you do, friends, you're working on data. You're pulling that data into a different application. be it business intelligence applications like Tableau, Power BI, Click, or maybe Python, right? So to establish the connection between your database and these tools, you need APIs, application programming interfaces. Okay, APIs are application programming interfaces, which is going to establish an interface between two applications, doing some programming. When you do some programming and establish connection between two applications, it's called as establishing the interface. That's why it's called as APIs. And from there, when you deploy a model on mobile application or web application or your business application, etc., there also you need an application programming interface. Same is the case with this. If you want to show your reports on mobile or on desktop or on any of your business applications or on some website, then you need to establish a connection between these systems and your mobile application, between the system and your web application, or between the system and your business applications. Establishing all these connections and ensuring that everything happens smoothly without any challenges is the role of a data engineer. Okay, various other roles such as data architect, data modeler, and chief data scientist, right? Chief data officer. There are many other roles, friends. Without getting into all that, these are the things that one should be aware of. This is good enough for you to get started and get into the career of data science. Okay, so I'll remove this. And then, sorry, I've taken a slight detour to explain this because a lot of people keep asking this, and it, I believe, makes sense for you all to understand what is the difference between these broad terms, etc. Okay, now within data science, you have something called as data mining, like coal mining. You keep digging data, and ultimately you will get very good insights, and based on those insights you can take actions. That is data mining. Okay, for example, say someone has been writing about companies or on Twitter, on Facebook, on news articles, etc. People keep writing about performance of different companies. Say you're a person who is extracting all those, tweets, Facebook comments, news articles, etc. about that company in which you want to invest. And you have done, say, sentiment analysis about all those articles. You have taken the data of a specific company, say Google, as an example only. Say you have taken Google, you have taken all the news articles, you have taken all the Twitter tweets, Facebook comments about Google for the last 3 months, 6 months, whatever. And then you have tried to mine the data to understand what is the sentiment. What is a sentiment? Is a sentiment positive? Are people talking positively about Google, or are people talking negatively, or are people neutral? So you're trying to understand these things. So what are you trying to do? You are trying to do sentiment analysis. So using data mining, you're trying to perform supervised learning, or maybe you're trying to perform unsupervised learning, or you're trying to perform self-supervised learning, or say you're trying to perform semi-supervised learning, or maybe you're trying to perform reinforcement learning. Whatever bunch of broad categories of algorithms you're trying to apply, ultimately you're trying to dig data. You're trying to get some new insights from the data. Those insights will help you make meaningful decisions. Within this data mining, there is a field called as machine learning. Sometimes data mining and machine learning are interchangeably used. Okay, they are interchangeably used. They can be interchangeably used as well. However, a lot of people correlate machine learning with building predictive models. They correlate it with predictive modeling. Predicting who will default on the loan, predicting whether your credit card transaction is going to be fraud or not upfront, predicting whether the stock value go up, will it go up or come down, predicting whether your portfolio, okay, of investments, is it going to give you profit or loss, various things. Within machine learning, you have a field called as deep learning, which is becoming extremely prevalent. In the good old days, people were not using deep learning algorithms for finance. Okay, why? I'll just quickly explain here, but then deep learning means or let me use this, applying neural network algorithms. But these neural network algorithms are considered to be black box techniques. If I use a term, cuales su nombre, sentence, cuales su nombre, how many of you will actually understand what I just spoke? Okay, not many people. Right? Cuales su nombre is a Spanish, saying. I'm not saying it's a sentence in Spanish. So what I mean to say is, it is black box for people who do not understand that language, Spanish language, people who do not understand, for them it is black box. On similar lines, neural network will give you good results, amazing results, very good accuracies, but it is black box, meaning you cannot understand what is happening. You cannot interpret the results. Okay? But a lot of regulatory bodies have put conditions, especially in the space of finance, saying that whatever predictive model you build, there should be explainability in that. If you're rejecting a loan of a person, you should tell exactly on why did you reject the loan. Is the age of the person, is that guy very old? Okay, and the income is low? Or what is the reason why you have rejected the loan? You should be able to explain. Such explainability does not exist in neural network algorithms. So it does not have any explainability. No explainability. Since there is no explainability, people started avoiding that. In especially finance or life sciences, healthcare kind of domains where regulatory norms are very strict. Later on, DARPA, US DARPA, and a lot of people are doing research and they're trying their best to bring in explainability into deep learning models. As and how they're trying to get explainability into the deep learning models, these deep learning models are also picking up. Okay, so ultimately, whatever technique you apply, at the end of the day, you end up implementing an AI application. At the end of the day, you end up implementing AI application. So data mining is not just about extracting customer behavior, it's all about analyzing the data, whatever be the data, right? So these are a few things that one should be aware of before they get into the field of data science or data analytics, etc. So let's move on and try to understand a few insights pertaining to financial analytics. Always, I believe in economies of scope. You might ask me, hey, what do you mean by economies of scope? Friends, economies of scope simply means the more I know from job and salary point of view, the more I know, the more the company is going to pay. Scope, what all do you know? A lot of people are getting trained on data science. Say you have two resumes, one of Mr. A and another of Mr. B. Friends, don't worry, we will slowly get into the concepts. As I've promised, at least 6 hours of training is what I'm going to deliver. I'm going to talk about interesting insights, and it will be a different dimension altogether. What is efficient frontier? What do you mean by CAPM models, capital allocation pricing models? And how do we implement that in Python? Okay, what do you mean by Markowitz optimizer? And those kind of things, certain simulation aspects as well. We'll talk. I'm going to impart sufficient knowledge, right? But let's clear the basics first. And these things will certainly motivate you, all right? Say you have Mr. A and Mr. B. Mr. A has done data science training. Mr. B also has done data science training. Both of them appear for interview. But then Mr. A has also done financial analytics. So this guy also understands about finance and how how projects are delivered in this specific industry or domain. He or she knows that. This guy is not trained. Whom are you going to hire? I, as a company, if I'm paying some money as a salary, if someone knows both, I would rather opt this guy. I would rather choose this person as opposed to choosing this guy, right? Because if you take Infosys or TCS or Wipro or Accenture or Deloitte or IBM, you name a service-based company, guys, they will have financial services insurance as one of the key industries. Okay, as one of the key industries you'll have. And when you're hired, they will hire in Infosys, but they'll assign you to financial services insurance vertical. Okay, if you know that. And also another beauty is that any bank or any insurance company or any financial company, NBFC, etc., would readily pick you. They'll readily pick you. Because you are a person who knows data science concepts, you know exactly how to implement it into the financial domain. And you also have learned more about the financial domain, right? New concepts. So why shouldn't I hire you? Why should I hire some other person? Okay, that's the motivation part. So certainly any data scientist should have knowledge about domain. And we are giving you an opportunity to learn one domain probably every month. 14 domains are happening in parallel at the same time. The reason why we plan all these domain analytics trainings at exactly the same time is because we want people to specialize on only one. A few people get greedy. I will learn this, I'll learn supply chain, I will learn e-commerce, I'll learn healthcare, everything. Stick to one, get a job. Specializing in one industry itself will take years together. Okay, so wisely choose your domain, and financial domain is considered to be green. Okay? Meaning it's always evergreen. Always you'll have opportunities in that. Okay, and financial jobs requiring AI skills. AI contains data science contains data mining, that contains machine learning, that contains deep learning. So finance jobs requiring AI skills increased by 60% last year, according to CNBC. By 2030, some 400,000 full-time jobs in capital markets Capital markets includes asset management, investment banking, brokerage. Okay. And all these full-time jobs will be lost as technology and AI is going to supplant humans. It's going to dominate humans. If those many jobs are going to be lost, who are the people who will be benefited and who are the people who will get jobs? Remember in the good old days when people told we will have ATM machines, automatically you can get the money. Then a lot of people on the cash counters in the bank, people who sit on the cash counter, give the cash. They were like, oh my God, I'm going to lose jobs. But on the contrary, what happened is ATM machines generated a lot of real estate revenue. So there were jobs created there because you need space and all that. You pay rent. And a lot of technology guys got jobs because they need to install the software, develop the software, ensure that the right amount of money is disbursed. The ATM card manufacturers, they also got benefited because a lot of orders came in. And then security guards who have to man or who needs to guard the ATM, they also got jobs. And these cashiers were put on different other jobs where this no-brainer kind of job, kind of role doesn't exist. So it's called as brain drain, underutilizing the human potential. If your cash counting, giving away the cash, etc., can be done by an ATM machine, then why do I need you? I'll use you for some other purpose. Okay, for some other purpose where human beings are actually meant to work, right? That's how human race develops. So while on one side people were losing jobs, on another side a lot of other people were getting jobs, especially if you upskill yourself. Okay. And then almost 1/3 of financial services jobs could be displaced by automation by mid-2030. Who is saying this? PricewaterhouseCoopers. This was told by Financial Times. Then leading organizations expect to double the number of artificial intelligence AI projects within the next 1 year. And 40% of them plan to actually deploy AI solutions by the end of 2020. That's what the prediction was, and it became true. It became a reality. This was a source from Gartner. And friends, in 2017, financial analytics market was worth $5.89 billion, and it is going to grow to $11.57 billion by 2023, by next year. Yeah, almost 50% growth. Sorry, almost 100% growth is what the world would experience, right? And then demand for AI talent has doubled. Adobe has to say this, right? And they say that technology and financial services companies are currently absorbing 60% of AI talent. So once you specialize in financial analytics, suddenly what happens? Your service-based companies anyways will have financial services insurance as a key vertical. It generates huge revenue for them. They get huge profits. Hence, that will be a key vertical. Vis-a-vis, companies such as Bank of America, HSBC Bank, Standard Chartered, all these have opportunities for people with financial analytics knowledge. What are a few other applications? How much time do we have here? We can complete as promise applications part of it for sure now. So the beauty here is that there are a lot of algorithms which exist, right? And I will talk about a few of the interesting or very interesting use cases. One is people started looking at something called as patents. Nowadays, fintech. Fintech means financial technology. Fintech companies are growing in leaps and bounds. be it Paytm, right, or be it UPI, which Indian government has come up with, right? A lot of companies in the space of fintech are doing tremendous job. And these fintech companies come up with patents. Patent means any innovative solution or any innovative product that they come up with, they will apply for intellectual property. They will say that that's my intellectual property and I want to patent it. I want to register that so that the other people do not copy that. And in one of the machine learning use cases, what people have done is they've looked at fintech patents. How many patents, which patent was that, what was the category of that, in which year was that patent filed, right? So on and so forth. And then they looked at by what extent is this improving the performance or profitability rather. Profitability. Okay, by what extent is this improving the profitability of financial industry? Very interesting thing to be solved. They looked at return on asset, or rather return on equity. Number of patents filed by a specific company, which year was it filed, in what stage is it approved or not? A bunch of inputs were looked at, and then does it actually improve the profitability or not? That is simply put, return on equity. Okay, and then people also came up with regulatory advisor. Okay, they came up with some intelligent regulatory advisor. You have a lot of regulatory norms, right? Reserve Bank of India, right, would come up with its own norms. Different countries have different bodies which govern them. They come up with a lot of regulatory norms. If I have an intelligent regulatory advisor, that advisor is going to suggest me whenever I'm going off track with my regulatory norms. You need to maintain minimum this much amount of cash reserve. That is a minimum requirement for a bank, right? So there is some number, that minimum amount of cash should be there with a bank always. Every ATM machine should have minimum so much of money, right? So many notes of 2,500, etc. should be there. So I'm just giving a few examples, okay? When the amount of cash in your bank reduces below that, immediately it will send a trigger. Okay, it will also predict that, you know what, in the next 3 months, you might be falling short on your cash by 10 crores, right? By 10 crores. Crore is a term which they are using in India. Anyways, 10 crores. Or I would say $100 million, whatever you want to term. Right? So that can be predicted upfront. Then you have something called as automated monitoring. In this automated monitoring, which is also called as risk sensing, you're going to extract the content which is posted online. You're going to extract the social media content to determine market abuse. Is someone trying to, write negatively about your bank? Or is someone trying to abuse you? Right? Or are the news articles being published about us so negative? that people reading about those articles will take away the money which they have invested in your company. Then your entire bank balance would come down. As a company, your money that you have would come down because everyone is pulling at you. So these kind of things are very, very important. We would have observed that somewhat suddenly some rumor is circulated, rumor gets circulated, and because of that rumor, people rush to ATM centers to withdraw money. Suddenly, for that particular bank, the entire money would drop. Okay. Then people have come up with also automated reporting. In automated reporting, what happens is you use online complaints communication. Automatically, whatever reports you need to send to various complaints bodies, you can automate that and readily we can send it. There's also something which is happening. Okay, and then various things such as if I have a regulatory policy, okay, some regulatory body, so Reserve Bank of India has come up with a specific policy, and if you as a company or a bank implement that, okay, policy modeling, I would call it as, if you implement that, what is the impact going to be on your bank? So there are certain contract analytics which happens. There'll be a big contract, a lot of regulatory norms. You analyze it and then figure out what exactly this means and what will be the impact of implementing this particular regulatory policy. And employing blockchain technology to automate the monitoring and compliance. All these things are the various interesting stuff that happens. You can develop bankruptcy prediction models. Bankruptcy prediction models. Which are the companies or which are the banks which might file for bankruptcy? You have a lot of credit scoring models which will predict whether you are a person who will default on the loan or not, that means take the money and run away or not. You have a lot of credit scoring models. Okay, then we also have a lot of models in the space of fraud and compliance. Like you have credit scoring models. There is a model which is called as financial distress prediction. What these kind of models do is there some kind of distress in the bank operations? Okay, is a specific bank on the verge of collapse? If you give money to people such as Vijay Mallya, Nirav Modi, Mehul Chokshi, all these kind of folks, that's a huge money that you give, right? Even to this guy, I'm unable to recollect the name, Sahara Group, what is his name? Sahara Group guy, and he is now behind bars, if I'm not mistaken. He didn't run away from that respect should be there anyways. But you know, all the companies were experiencing some distress at some point of time. Even Anil Ambani, for that case, you know, his Reliance Group of arms were experiencing some kind of distress. Yeah, Sahil, right? So good to that. So here, you can also predict such kind of a distress for the banks which are running. Then you have robo advising, you have algorithmic trading. All these things are the amazing things that we have. Then we have something called as index replication models. Index replication models. Hopefully, I'm going to touch upon this, and we will touch upon this by looking at something called as autoencoders. Okay, I'm going to touch upon this, and then you have some kind of volatility forecasting. You have a lot of models which actually do volatility forecasting. You can also use those. Yeah, sorry, I was thinking on where I am. Okay, so let me write it down. You have volatility forecasting. Meaning, what is the fluctuation going to be in the market? Okay, you can actually do that. Then you have a lot of techniques which include analyzing the news articles and all that. And by analyzing the news articles, you get to know about the sentiments, and based on those sentiments, you actually take a decision. Okay? This is also another thing which we have. Okay, and you can evaluate something called as value at risk. Sorry, my bad. Yeah, I'm visible now. Right? Yep. Okay. You can identify risk prediction models, and you can also use something called as generative adversarial networks for doing the same. Robo advisors using reinforcement learning. Advisors using something called as reinforcement learning. So on and so forth. Okay. But for us, in the initial discussion, which will be from the next module onwards, we will talk about investment banking. Where to invest, how to invest. What do you mean by efficient frontier? What do you mean by CAPM models, capital allocation pricing models? Okay. When can you use Monte Carlo simulation? So on and so forth. Majorly, we'll focus upon these. And of course, I'll focus upon a few of the deep learning algorithms such as autoencoders, reinforcement learning, so on and so forth. And yeah, there are a bunch of approaches which are available. Not sure how many approaches we are going to look at, but yeah, quite a few things which are worthy to be discussed. Certainly, we shall discuss. So I'm just going to open a new presentation. To talk about these things, right? So we will talk about risk return primer. We are going to talk about risk return trade-off. We are going to talk about indifference curves. We are going to talk about utility function, quadratic utility, so on and so forth. We'll talk about a bunch of these things. I think we are almost there at the end. So I'll do one thing. I'll stop at this point of time. And tomorrow when we connect, let's talk about risk return primer, risk return trade-off, indifference curves. What do you mean by utility, which is equivalent to happiness? And what is a quadratic utility function? So on and so forth. So thank you so much, friends, once again for joining in. And tomorrow we'll connect and take it forward. But before that, all these sessions will be streamed on YouTube channel. Okay, I would request you all to subscribe to, of course, 360DigiTMG YouTube channel. But I started a specific channel long back, but then I didn't make it popular for some reason. But then I would request you all to click on this and subscribe. All these videos would be made available on this YouTube channel. Okay, and from tomorrow it will also be hopefully YouTube live. Okay, friends, thank you so much. Take care. We'll connect again tomorrow and take this discussion forward. So let me stop the recording.